Before the Big Bang, the James Webb Telescope will change everything. Who or what created the universe? Were we alone in this vast cosmos before the Big Bang? Innumerable questions like these have kept scientists up at night for decades. They plan to sleeve projects and missions to gather as much information as possible about our origins and the universe we live in, but no technology existed. For decades, scientists worked tirelessly to create a giant telescope. Webb Space Telescope is expected to help us understand how the cosmos came into being, but doesn't have the ability to do so. We're glad you have found us, your one-stop shop for all things space-related. Check out today's video to see if the James Webb Space Telescope can answer our creation's questions or not. After a tense launch on Christmas Day, the James Webb Space Telescope, or JWST, has commenced its imaging mission of the universe's origins. NASA's largest and most powerful telescope, the $10 billion James Webb Space Observatory, will study the universe's history from its beginning to its current state. There are several large space equipment like the Hubble Space Telescope at this observatory, making it one of the best. More than 13.5 billion years in the past, the infrared light emitted by the earliest galaxies will be seen by the JWST. This will provide a glimpse into the universe's formation as we know it today. The James Webb Space Telescope is not a telescope for seeing the beginning of the universe, but rather a telescope for observing the universe's history that we have never seen before. Will James Webb carry out these tasks, or will it be unable to see for tens of thousands of light years? The Webb telescope is like a time machine that can take you back to the beginning of time when looking at distant galaxies and stars. Unlike Hubble, which only observes shorter wavelengths of light, Webb will be able to detect longer ones. It has been said on the NASA website that Webb will be capable of observing the earliest galaxies in the cosmos because of its larger wavelength. We'll see if you are a bumblebee 240,000 miles from the planet. That's the distance between the Earth and the Moon. That's what Mission Senior Project Scientist John Mather of NASA's Goddard Space Flight Center in Maryland stated. Science equipment on board the JWST allow for observations in the visible, near-infrared and mid-infrared spectrums. Electromagnetic radiation with wavelengths longer than visible light but shorter than radio waves is infrared light. NASA's Goddard Space Flight Center's Deputy Technical Project Manager for the James Webb Space Telescope, Paul Geithner, explains why infrared research is essential. For one, the ultraviolet and visible light emitted by our universe's early stars and galaxies as they formed is now emitted as infrared radiation because of our galaxy's rapid expansion. It's now been 13 billion years. As soon as the sun begins to rise, Webb will be on the prowl. Another possibility is that the formation of stars and planets take place amid dense cloud of gas and dust. Because infrared light can pass through clouds, we can see what's happening. The universe's evolution from a simpler state of hydrogen and lithium to the one we see today remains unknown. Still, the Webb telescope will allow us to observe far-flung regions of space over time never previously seen, helping us address these vital questions. The Webb will use ultra-deep near-infrared surveys, low-resolution spectroscopy and mid-infrared photometry to discover the first galaxies. Reionization will necessitate high-resolution near-infrared spectroscopy. Thanks to this, the James Webb Space Telescope will be able to observe things no one has ever seen before, so we may be closer to discovering the truth of our existence. A giant telescope, like this one, argues astronomer John Mather, should be used to study the whole cosmos. Further, he stated we'd want to know how we got to this time. The beginning of the universe as we know it. We'll take a closer look to see how it went. We have theories and forecasts, but we don't know for sure. The science mission of the James Webb Space Telescope is divided into 4 areas to discover the answers: reionization of galaxies, the generation of stars, the formation of protoplanetary systems, and the emergence of life. Referring to the universe's early moments following the Big Bang, when the universe as we know it today was born. Until the universe had cooled sufficiently, the universe was a sea of particles, and light was not visible until these particles began mingling. In addition, the James Webb Space Telescope will investigate what transpired following the first formation of stars. The epoch of reionization following the formation of gases is known as this period. One of the James Webb Space Telescope's aims is to examine the evolution of the earliest galaxies to understand better the spiral and elliptical galaxies that we observe today. Scientists are also trying to figure out how we ended up with such a diverse collection of galaxies and the current mechanisms through which the galaxies form and come together. The infrared sensitivity of Webb will allow astronomers to compare the oldest galaxies to today's grand spirals and ellipticals. As billions of years passed, scientists will better grasp how galaxies form. Some of the most well-known star-birthing regions may be found in the Eagle Nebula. A star's radiation pressure blasts the surrounding gas away as it grows in size, resulting in the formation of stars. However, it isn't easy to see within the gas. The James Webb Space Telescope's infrared eyes will be able to detect heat sources in these cocoons, such as the formation of stars. Fourth, and perhaps most critically, many extrasolar planets have been seen in the recent decade, thanks mainly to NASA's planet-hunting Kepler telescope. The advanced sensors on the JWST will be able to better look at these planets, including their atmospheres, which may be imaged. Scientists can better predict whether or not a planet is inhabitable or habitable, if they better comprehend its atmosphere and formation conditions. NASA's Deputy Administrator Pam Melroy claimed this was a once-in-a-generation occurrence. It's an exciting time to be a part of NASA as they continue to push the envelope of what's possible. Throughout history, humans have looked up at the sky and pondered the question, what is the universe's origin? And is there life elsewhere? This time, Will take the blinders off and reveal to us how the cosmos were formed. As Melroy put it, this telescope epitomizes the public good for research and exploration, for which our space program was created. Exoplanets will be studied using the transit method, which includes observing the dimming of stars when their planets pass in front of them. Radial velocity will be used to determine the planet's mass, since it is a method of detecting the wobbling of the stars induced by planetary gravitational pull. Next, Webb will use timepieces, which are telescopes that look into the corona of a star, to conduct spectroscopy in the planet's atmosphere, allowing him to take explicit pictures of exoplanets circling nearby bright stars. Although an exoplanet's picture is only a snapshot, astronomers may glean information from it, including seasonal color variations, vegetation rotation, and climate. There is a good chance that the JWST will be able to identify comets and other ice-based planetary bodies outside the solar system. Comets and Kuiper Belt objects may shed light on the beginnings of our planet. Webb has made it feasible for scientists to conduct tests in our solar system. Its near and mid-infrared spectral coverage will help NASA's other solar system explorations. The Webb Space Telescope is a masterwork that has never been constructed. With luck, James Webb will not only transform astronomy, but also provide us with the hope that we can discover the genesis of our own life. The James Webb Space Telescope is and soon will become one of NASA's major, or perhaps the major milestone in NASA's trajectory in terms of discoveries, explorations, and achievements, as this telescope will do something that has never been done by anything else before since the evolution, or you can say since the origin of mankind. Are we going to be able to receive the answers we've been looking for? Let us know what you think about the space provided here. Please consider it giving a thumbs up and subscribing to the channel by clicking the bell symbol if you liked the video. Until then, have a wonderful day and thanks for watching.